All right, 7.1 and 7.2, graphing exponential growth and decay functions. So technically 7.1 is exponential growth and then 7.2 is exponential decay. But we're just hitting the very basics of this just so that you've seen it because from what I have heard, part of the math on the SAT can be these kinds of things. So I just want you to have seen some of like the basic exponential growth and decay functions so that if you had a question like that come up on your SAT next year when you take it, or your PSAT whenever, that you would be ready for it. So the parent function for exponential growth we have the function f of x is equal to b to the x, where b is greater than 1, is the parent function for the family of exponential growth functions with base b. So what this looks like, and then we'll talk about the domain and range of it as well. An exponential growth function is going to look something like this. Sometimes it's a little bit more flat and then goes up. It's just depending on this like what the value of your function is. And so one thing about these is that there is an asymptote on the x-axis here, because the exponential growth function can't cross it because it can't be negative. So these points here would be like 0, 1, and then you'd have a point up here, 1b, and then this is the function f of x is equal to b to the x for b greater than 1. The domain of an exponential growth function is all real numbers. Or if you wanted to write it as negative infinity to infinity, you could also do it that way. And then the range is y is greater than 0 or, or we could write it as 0 to infinity, like that. All right, we're going to do the same thing but for decay, and then we'll jump into some problems from both sections on that as well. So the parent function for exponential decay if you wanted to simplify the word exponential, since you said something about it, you could write EXP.
Yeah.
As long as you know what that means. The function f of x equals b to the x. So obviously that looks similar, but the stipulations on b are different, where 0 is less than b is less than 1. So basically that means that b is a fraction between 0 and 1. Could be a decimal. I was going to say usually they give it to you as a fraction, but some of the books actually do more with decimals. It doesn't really matter. Is the parent function for the family of exponential decay functions base B. Does everybody have the top one so I can slide it up? So the decay function starts high on the left and comes down like this. Got this one really close. It's got the same thing. We still have an asymptote here on the x-axis. Can't cross it. This is the point 0, 1. This point over here is the point 1b. Whoa, come back. The domain for this is still all real numbers. And the range is still y is greater than 0, or we could write it as 0 to infinity.
The domain and range are the same.
Yep. Now, this is obviously the parent function. So sometimes these things are going to get shifted down. So the asymptote isn't necessarily always on the x-axis, right? It would be wherever it's been shifted down to, just like we had other graphs that get shifted. We're not going to do anything that's like super, super crazy. But I just wanted you to see, a little bit of this stuff. So I'm going to start with problems from 7.1. So basically these are all going to be exponential growth problems. I usually graph about 3 points for each of these, just because of that usually gives you enough of a picture of what you need. I usually graph -1, 0, and 1 like in a table, or I put those x values in a table and then I find what the y value is and then I just plot those 3 points and I go from there. If a number is ever really, really large, some people like to plot like -1, 0, 1, and 2. A lot of times when you get to 2, it gets to be a really big number. So if you get to a really big number, I would just not plot that point. Like, even if it means you only put 2 points on the graph, because some of them are just so big that it's not even worth it. So, again, I'm going to put mark here. These are 7.1 problems. So I'm on the right page. Start with the basic one. Number 6. Y equals 3 to the x. So I set up a little table here for x and y. So I'm going to put in -1, 0, and 1 for x. So then my y value, and sometimes I'll show you if you feel like you need to show the step of like doing the work in here. Sometimes I'll put an extra row in here to show the step of doing the work. That's usually how I showed in Algebra 1. Usually when I get to Algebra 2, I don't leave the gap, but if you feel like you need that, that's totally fine. So that means that into this equation, I'm plugging in each of these x values here. So if I have 3 to the -1, what does that equal to? 1/3. 3 to the 0. 1. And 3 to the 1.
3.
So now I'm going to take those set of 3 points and I'm going to graph them over here. So I mark off my -1, 0, and 1, and then I know that I need to go up to 3. So at -1, I have a point at 1/3. And a lot of those points that are like the fractions get really hard to like get them exact. As I've said many times before, I'm not getting out a ruler, just get it approximate. At 0, 1, I have a point, and then at 1, 3, I have a point, and then I just connect and it's rounded off like that.
That's not too hard.
10. Y equals 2 times 4 to the x. So I'm going to do the same thing. So one like this might be useful to have that middle step spot if you want it. I'll do it for now just so we can see what's happening. But Still negative 1, 0, and 1. So now what I have is I have 2 times 4 to the negative 1. So that 4 to the negative 1 becomes what? 1/4 times 2? 1/2. And then I've got 2 times 4 to the 0. Just 2. And then I've got 2 times 4 to the 1. 8. So if you have one like this, obviously 8's kind of a big number. I mean, it's not like crazy big. When numbers get bigger than 10, that's kind of when I stop graphing them. But if you wanted to count by 2s, you could do that. I'm probably just going to count by 1s because it's not that bad. But if the numbers get big and you want to count by something different, that's fine. Just make sure you label if you're counting by something different. So at negative 1 and 1/2, I have a point. At 0, 2, I have a point. And then at 1, 8, I have a point. So this one obviously is getting steeper much quicker. Now, this is one where, let's say you chose to use, like you chose that you're like, I want to put 4 points on the graph, or you just chose to pick a different set of points and you used like 2. If you plugged in 2 here, you would have 4 squared, which is 16 times 2 is 32. That number is much too large to graph, so just don't graph that point if that happens. One more of these ones. 18, y equals 3 to the x minus 2, and then minus 1. So this one's a little bit different. I might want to be strategic and not pick negative 1, 0, and 1 here. Does anybody know why? Or see maybe why I wouldn't want to do that? Yeah, potentially, right? Because this is x minus 2. So if I put in negative 1, that would be to the negative 3. It's going to end up being a really small number, right? If I put in 0, that's to the negative 2. It's still a pretty small fraction. That's not really helping me a whole lot. And so just like, yeah, I would probably pick some bigger numbers like that I can deal with. So maybe 2 would be a good one to start with because 2 minus 2 is 0, so that would be something easy to deal with. So I would probably start there. So I would do like 2, 3, and 4 for this one. Now make sure you pay attention to, also don't forget this minus 1. So I've got 3 to the 2 minus 2, so that's 3 to the 0, and then minus 1, so what is that? 0. And then I've got 3 to the 1 minus 1. 2. And then I've got 3 squared minus 1. 8. So I'm still going to set my graph up more or less the same, except for I'm obviously going over to 4 now on the right-hand side. So now I have to watch. So I have a point at 2, 0. So that's here. I have a point at 3, 2. And then I have a point at 4, 8. Now, what you don't really see with this one is that what's technically happened, because we have yet to have a point that fell on the x-axis, right? Everything's been above it because in our parent function there is an asymptote. This minus 1 here says that this is going to move the graph down. So it's moving it down 1 spot. If it's up here in the exponent, it's moving it right and left, opposite the direction of the sign. So this one went right 2 spots. Now, you don't need to worry about that. I just want you to see that's why this one looks different. So technically, this one would be coming down here like this and coming, and then I would officially have down here at -1, I would have an asymptote that it's not going to cross that value there. So you don't, like I said, you don't need to worry about that. I just want you to see what the basic graph looks like, but I just wanted you to be aware of that. Skip those for now. I may decide to come back to those in the future, but all right, I'm on to 7.2 problems now. So all of these have been exponential growth. One thing that I may ask you on like the quiz, I may have you tell me, is this an exponential growth or a decay problem? So just be aware of that. But if it's growth, it's going to be going up like this. If it's decay, obviously it's going to be going down. Pretty obvious, but let's look at 8. Y equals 1/3 to the x. So back to choosing, or what I would do is -1, 0, and 1. So if I plug in -1 for x, what do I get? 3. If I plug in 0. And plug in 1.
1/3.
Yep. So then set up my graph. So now at -1, I'm up at 3. At 0, I'm at 1. And at 1, I'm at 1/3. So this one is obviously decay going down. And big thing is just, again, make sure it doesn't technically cross the x-axis. It can get really close, but it can't cross it. I'm gonna jump down 18. Y equals 2 times 1/3 to the x plus 1, and then minus 3. All right, so again, I probably want to be strategic in my choice of points, right? Not that -1, 0, and 1 are going to be a problem. I mean, they really aren't going to be that big of a deal. But I might want to be a little bit more strategic to pick some points that could make my life a little bit easier.
-2, -1, 0.
Yeah, that would probably be the easiest ones. And then that also would cause this to flip the fraction, which is nice. So, I'm going to leave space to put the work on this one. All right, so -2, -1, and 0.
3, 1, 1/3. No, fart.
So this would be 2 times 1/3 to the -1, and then minus 3. So 1/3 to the -1, that would be 3 times 2 is 6, minus 3 is 3. And then I've got 2 times 1/3 to the 0, minus 3. So that's just 2 times 1 minus 3. -1. And then 2 times 1/3 to the 1, minus 3. So this would be 2/3 minus, if I put this over 3, 9/3. So negative 7/3. Or negative 2 1/3. All right, so then graphing. So at -2, I have a point at 3. At -1, I'm at -1. And then at 0, I am at -2 1/3. So this one is coming down like this. And again, this went down 3, so that would mean that my asymptote would be down here at -3. So if I kept picking values, I'm going to get closer and closer to -3 down here on the y, but I'm never going to cross it. Questions about these? Feel okay with them? Mostly just plug in numbers and then plot the points. So
Yeah.
all right, I'm going to have to do it this way. 7.1 problems. Let's do 7, 13, and 17, and then 7.2.
Can we have the same paper though, right?
Yeah. Let's do 7, 9, and 19. So you got about 20 minutes. I think that should be enough time.